Alright everybody, so today we are going to review some of our strategies, or one of our strategies, for long division. And tomorrow we will get into another strategy for long division. For any adults or older students watching that didn't learn any of these strategies, it's important that we stick to these when solving long division problems, because it's really in the research behind students learning division that we start with place value strategies and then move into the standard algorithm that we all learned growing up as more of a memorization tactic. So this year in 4th grade and as well in 5th grade, students will be practicing these strategies we're going to go over today and tomorrow. But it is a 6th grade standard for learning the standard algorithm that we grew up learning for long division. So first we want students to understand why we're doing what we're doing, what is division, and then we move into the quicker, faster standard algorithm, just memorizing facts sort of strategy. So that is kind of the why we get into this, and now we're going to do the how. Let's start off with some quick vocab. So when we are looking at a division problem like 3 divided by 42, which might be written this way, or might be written this way, 42 divided by 3, here are what these different parts of the division problem are. So first we have the divisor. So in this case that would be the 3. The divisor is the number that does the dividing. The dividend would be 42 in this example, and that's the number that will be divided. So division is essentially just putting a number of people or things into groups. So in this case, we might have 42 people that we want to split into 3 groups, or we might have 3 people that we want to give 42 things to. Either way, we are dividing this number 42 into groups of 3 or into 3 groups. So that's where long division comes into play to make it easier. We could just subtract 42 minus 3 until we are left with nothing. Or we could skip, it's kind of like a jump start to skip counting. And then when you get your answer to a division problem, we call that a quotient. This word is going to be important as we get into today's strategy. So a quotient is the answer to a division equation. All right, so let's get into today's strategy. It's called partial quotients, and it's probably better known to our students as the Magic 7 strategy. You might also hear it be called the Big 7 or even the Hangman strategy, and that's because we turn this division symbol into what looks like a Big 7, a Magic 7 if you will, and I'll show you how we're going to use this. So because division is all about how to put things into groups, into multiple groups, we're trying to see how many groups of 4 fit into the number 92. So the Magic 7 strategy starts off with having kids think of easy numbers that they could pull out of 92. So for this one, I might start with 10 groups of 4 because that's an easy number for me to multiply and take away from 92. So I'm going to record my how many groups of 4 to this side of the 7. And I think to myself, well, 10 times 4 is 40. So I'm going to subtract that amount from the total. So I've just taken out 40 groups of 4 from 92, and I'll see how many are left. So that'd be 2, 4, 9, 8, 7, 6, 5. So that'd be 52 groups of 52 would be left. So I took out 40. I think I can take out another 40 from what's remaining because I have 52 remaining. So 10 times 4 would get me 40. So I did another group of 10 groups of 4 So another 10 groups of 4 I just took away from my total. And so now I'm left with 12. Now I can think back to my 12 facts. What do I know that I can multiply by 4 to get me to 12? Well, I know 3 times 4 equals 12. And I'm left with nothing left over. So, in order to find my answer for how many groups of 4 fit into 92, all of these groupings of 4 that I subtracted in parts, I'm going to add together. So I found some partial quotients, some partial answers, and when you bring them together, they're no longer partial. Now they will be a whole answer. So all I have to do is add these together, which would be 23. And we can put our quotient, our final answer, up at the top here. So 92 divided by 4 would equal 23. This strategy also works when it's not an even number. So when you can't divide something evenly and you know you're going to get a remainder. So we know that 62 can't be divided by 5 evenly because it doesn't end in a 5 or a 0, but we can still use this strategy. So I'm going to make my big 7, and I'm going to think how many groups of 5 would fit into 62. I'm going to start off with that easy number again, 10. 10 groups of 5 would make 50. If I take that away from my total, I'd be left with just 12 groups of 5. So I think of my 5 facts, I know 5 times 10 is not going to work again. That would be 50 groups. I can't take 50 away from 12. So I have to think smaller. So I could think, well, 5 times 2 equals 10. I can take away that from my total, and I'd be left with just 2. Now I can't pull out any more groups of 5 from this 2, so that becomes my remainder, and then this would be my quotient here that I add up, which would be 12. So my answer now becomes 12 remainder 2. Let's look at some more examples. So the next problem that I'm going to do is 782 divided by 5. So I'm trying to see how many groups of 5 fit into 782. Now, because I have a number in the hundreds place, if I just started off with 5 times 10, that would get me, that I would only be taking away 5 tens instead of 5 hundreds. But I could add a 0 to that 10, and now I could be thinking of 100 groups of 5 would be 500 I could take out of that. So now I have 382 left. Oh, 282 left, excuse me. So now I want to see how many groups of 5 fit into 282. Now if I took 100 away, that would be too many because I'd be taking away 500. So I want to think of 5 facts that will get me close to 282 without going over. So this is where I tell my students it might be nice to start making yourself a little cheat sheet to the side of 5 facts. So we already know that 5 times 1 is 5, so I'm just going to jump to 5 times 2. I know it's 10. 5 times 3 is 15. 5 times 4 would be 20. Now, if 5 times 4 is 20, that means that 5 times 40 would be 200, and then I could eliminate 200 from this total. So that's what I'm going to do. So I've got my divisor times 4 groups would be 20. So my divisor times 40 groups would be 200. See, I add a 0 to my equation. That would add a 0 to my answer, which is what I want here. So I can easily eliminate some more numbers. So now I only have 82. So now I think of 5 facts that get me close to 82. 5 times 5 would be 25. which I could have even taken away 50, because that would have taken away 250. 5 times 6 is 30. 5 times 7, 35. 5 times 8 equals 40. 5 times 9 is 45. And 5 times 10 is 50. So now I have this little cheat sheet to the side, which I can refer back to. I'm just gonna start with 5 times 10, because taking away 50 would be a good chunk from 82. So 10 groups of 5 would get me 50. I'll subtract that from my total. I'm left with 32. So now looking over to the side here, 5 times 6 would be 30. So if I take away 6 groups of 5, I'm taking away 30 from my total. So I'd be left with 2. I can't take any more groups of 5 out of 2. So this now becomes my remainder. And now over to the side here are all my partial quotients that I will add up to get my final quotient. So that would be 6, counting my tens, would be 4, 5, and 100. So 156 with a remainder of 2 would be my final answer here. Now, I also tell my students, if you know your 5 facts off the top of your head, this is not a requirement for this strategy. This is just extra for those that don't have these facts off the top of their head, so they have something to refer back to. Especially when we get into these bigger numbers where we're adding zeros, it might be helpful to have this just to refer back to. The last thing I want to talk about is the homework today is going to look slightly different from the type of problems I was just showing you. I wanted you to have the background of what Magic 7 looks like when you don't have anything written out, but your homework is actually going to be having you identify what the partial quotients are based on what someone subtracted. So here's how we would solve this kind of problem. So we see that the equation is 380 divided by 4. So this problem was seeing how many groups of 4 fit into 380. So when this problem was first solved, we want to see how many groups of 4 would get someone to 360. When we were just looking at our 4 facts cheat sheet, I'll just bring this to the side here. You'll notice that 4 times 9 is 36. So if 4 times 9 is 36, then 4 times 90 would have gotten that person 360. You're going to see blanks just like what I have written out here. This is what you would write in the blank. What did the person multiply to get this answer? So then, when they subtracted the 360, they were left with 20. Well, what times 4 would equal 20? Well, 5 times 4 equals 20. And they got an even 0. So then their final answer was 95. So you'd be filling in these blanks here. And I don't think you'd even need to rewrite it up here, as I remember. If not, or if it is there, then you would write the answer up there. Otherwise, you would just be filling in the partial quotients to see how did this person figure out this problem. Obviously, there's more than one way to do this problem, but you're trying to figure out, well, what did the person do in order to get these answers? What were their partial quotients? Let's look at one more. So here we have 273 divided by 7. So you're trying to figure out how many groups of 7 fit into 273. So you notice this person got an answer of 210, which means they multiplied something by 7 to get 210. I noticed that 21 right off the bat. I know that 3 times 7 is 21. So in order to get that extra 0 there, they must have did 30 times 7 equals 210. Then when they subtracted it out, they got 63. And then 7 times something is exactly 63. So you want to think back to your 7 facts. If you're not sure, start from a fact that you know, right? So we just talked about 7 times 3 was 21. We could keep going. 7 times 4, 28. If you didn't know that, you could count up from the last answer 7 more. 7 times 5, 35. 7 times 6, 42. Again, I'm speeding through this, but you could be counting up by sevens if you didn't know this on your own. So I want to get to 63. What would that be? 7 times 7 is 49. 7 times 8 is 56. 7 times 9, I believe, is 63. And I can double check that by counting up from 56, seeing if that's 7 more. 56, 57, 58, 59, 60, 61, 62, 63. It is indeed. So 9 times 7 is 63 exactly. These would be my partial quotients to get a final answer of 39. So that's what you're going to be doing during your math today. I encourage you to practice more long division problems using this Magic 7. It is my favorite strategy, but we will be going over one more strategy tomorrow that might look familiar as well, even to adults. All right, have a great Monday.